Hello everyone, am I audible?
Yes, you clear.
All right, let's wait for around 3 minutes, then we'll start our class today. Hello everyone, welcome to today's class. As I promised last week, today we'll be doing our hands-on. So, do you have any questions before I begin this section?
No questions.
All right, thank you. So, just
Wait,
to
Sam, she
clear
said
up,
she has. Wait, I thought you said you had a question.
oh, she said she had a question. She
No,
said no question.
no,
No
I said
questions?
no questions here.
Okay, I'm
Yeah.
dropping now. You guys have fun.
Uh, So just to clear up some questions that we had in our last class, it was Kangu asked me to kind of clear up and explain the difference between matplotlib and Seaborn. And these are just some of the few differences which kind of make sense and easier to grasp. So for matplot, you'll find out like it's more manual, so it's a low-level library where you have to control a lot of your coding. If it's anything you wanna change, talk about any component, you have to do it manually. So you have to code it. But when it comes to Seaborn, which is a high level, which is built on Matplot, this kind of becomes simpler. You don't have to change everything manually. And also it gives you more options and more features like themes and color palettes. So as you can see, Matplot is more of a simple kind of basic, sorry, that's a typo, basic plots. And then C1 kind of goes to the complex plots like heat map. Today you're going to see a violin plot. So most probably I have examples where it's the same plot for Matplot and the same plot on a Seaborn so that you can see the differences. So today's class will be working with the Castle's CSV. This is our data set today. And our first thing to do, obviously, is to import our libraries, pandas, numpy, matplotlib, and Seaborn. So the last two we kind of is what we're emphasizing on or what we're going to use today because it's more about data visualization. So then we read and load our data set. And you can see just from our data set how it looks like. We're not doing any cleaning up. This is just a data visualization class. But if you want to do any cleanups, if you want to modify your column names, so you want to modify the data types, you can go ahead and manipulate in whichever way you feel it's good for you when you're working with your analysis. So we look at the shape here, which gives us the number of columns and the number of rows. So we have 7 columns, as you can see right here. And then we have 50K rows going down. So this just shows you the first 5 rows. And then as you can see, we describe here showing only numeric. I know you can remember this. We went through this in our prior classes, just showing you the summary statistics of our numeric columns, which is engine size, year of manufacture, mileage, and price. Again, this doesn't make sense when it comes to the year of manufacture because we all know you can't get to this when it comes to the year. So you might change it to a date time kind of data type, but in some plots here that we've done, kind of makes sense just to leave it as a numeric, especially when you're trying to show a correlation, because with years they increase or decrease. So in this particular case, we're going to let it be the same way it is, just for the purpose of our data visualization. Again, DF columns, just to call it to show the columns that we have here. And you can see when we try to look at the data types that we have, this is a pretty good data set because it already has this converted to integers, object for strings, and then we have a float which gives you like a decimal values. So also, just to check if there is any null values, you can say it's 0. So as I said, it's a good data set for data visualization. And now we are going to get into our hands-on from what we discussed in our last class. So here is for feature distribution. So when you look at this plot, is a histogram showing the distribution of car prices. On the y-axis is the frequency. So you can see here. So this is how we call our y-axis, and this is how we label it. So here we are plotting a histogram, the data frame, as we called it right here, just for you to understand. This is where we're getting all that. So it's a data frame which contains our data set. So once you come here, you can see we are calling the column, the price column. So this is what we are working on. And then we have bins which are dirty. And you can remember what we discussed about bins, just showing the number of kind of bins that you had that they can appear here. So there's that you can change with whichever number you want, as long as it is relevant to your data or your plot that you want to kind of analyze or explain. So you can see the story behind this distribution is just to see when it comes to our car prices, was in terms of frequency, what car price is the highest in terms of frequency. So many of our cars kind of range below 25K in terms of price. So you can see showing this is the highest, and then as you proceed on, as much as expensive, then we have less cars which have sold in that price. So this is it's a matplot kind of code. Then down here we have a Seaborn. So as you can see, there's not a lot of difference, but it's simpler when it comes to Seaborn. And then we have this KDE trust here, sorry, through here, which is a kernel density estimate. So this is what is causing this to have this smooth line here. It just shows this curve just add this curve. Sometimes is necessary to have it or not. It depends with what you choose to do. So this is just what is different from this, and you can see having a seaborn kind of looks more clear than matplot here. Same thing, tells us a story about prices in terms of frequency, and you can see again 25K and below shows the highest number of prices or the highest number of cars that we sold in this particular range of price. Then again, we continue telling a story behind our data set. Then we go to mileage, try to tell the distribution of our car mileage. So from our data set, how does our car mileage kind of distribute across the data set? So you'll find out like 100K and below mileage has the highest number of cars. And again, you all know the obvious reasons of why it's decreasing, because again, when you have high mileage, it shows like your car is kind of overused. So most for a data set here just shows the reasonable mileage that a company can hold so that they can sell out their cars. And this is below 100K mileage from our data set. Again, you can see the comparison between Matplot and Seaborn. Straightforward, kind of simpler and less coding, but it's just the same thing. As I explained this, you can see this just shows the smooth curve, and that's the difference between the beans. Here shows more clear beans than right here. So next we go to a bar plot just to show how our car manufacturers from our data set, which manufacturer is kind of high and in terms of numbers or in terms of count, where do we get our cars from? As you can see from here, our top manufacturers are Ford and VW, kind of having the same number. So this just shows a story if you were to ask, if people just want to know where do you get most of your cars from. So from this plot, you can all tell it's clear that Ford and VW kind of show the highest number of cars that we have in this data set or in the store, or shows the highest number of cars per manufacturer that we have been able to sell out. So again, so we break down to a model. So when it comes to the top car models by listing, again, this is just the same plot as this, but kind of going down or kind of going deeper into the insights of our data set. And this shows all the models right here. And I guess they are all 15, as you can see from here. So you might ask, what does this line do? So this line just calls the model columns and then, sorry, the model column, and then it counts the value counts of the values that you have in this particular column. So if we go up, just to explain this, we are talking about this column right here. So we are trying to kind of know the number in terms of values or the frequency of each value or count of which value here, how it appears cumulatively or in sum in this column. So that's why we've called it down here. The same way you can see here with the top manufacturer, going to the manufacturer column and counting it, the value counts in terms of the values that we have. So same way we are doing here. We call it and then we filter out to have our new data that we'll be working with for this plot, which is they're all channeled or piped into this top model. Then X, you can see we are calling the values, which is the values. So when you see the index, when it comes to, I know there's this difference of what that the index and the value do and the values do. So the index is the count, and then the values just shows the labels or names. So that's why you can see from our X here, just shows the count, which is down here. And then for a Y, which shows the labels or names, is on the Y axis. Then this, all this, you can see we are calling from what we have already filtered up here. So it's just the same way we've done up here, but now we're going deeper into our insight or into our data set, which gives you different models. If you have any question, just stop me and then I'll be happy to answer you. So the next thing here we are doing is a violin plot, which we are using our data frame, our prior data frame. And again, remember after you've done this, you can always call this top module wherever you want to use it again, because since you've ran it, it will always remember what it's doing. And if you call this in a different line or cell, then it's going to remember this line here because you called it earlier or you ran it earlier. So it kind of gets stored and you can use it earlier in your data visualization or in your data analysis. So here we are trying to see the price distribution by fuel type. And we have three of the fuel that you have is petrol, diesel, and then there's hybrid. This is just example from our data set. And what this violin plot does is it just shows the probability density and showing where most cars are priced. And you can see we have a consistent kind of trend or pattern when it comes to the pricing. So it shows that all these types of fuel types or cars, they all fall under 25K in terms of price. So you can see they're all kind of near each other, showing that most cars have been priced in where you can see this shows the density. So these are the most cars which have been sold in terms of our fuel type. So we continue with our scatter plot. Now I've stopped using matplot. If you've realized, I'm back to Seaborn, which shows more features and easier to use. So we go to our scatter plot, which just shows the relation between two numeric columns. And in this case, we have mileage and price. And then we have this U here, which is a fuel type. This is just the fuel type, same up here, but just to show you how it's kind of distributed in terms of the fuel type. But most of our concern here is just to show the relation between price and mileage. And you can see this has a negative relation because the higher mileage, the lower the price. And the high prices, you can see they're all clustered at a low mileage. So it's a good plot just for the sake of showing the relation between price and mileage. But as you can see, there's a lot of points right here. So it's not really good to use it, but just to show the relation kind of makes sense to show the relation between the price and the mileage. So again, just to show you how you can go deeper into your analysis, you see here we are filtering with petrol and we are calling our DF, then which is our data frame. Again, data frame going to the column, which is a fuel type, which is equals to our petrol. So just to explain it to you right here, this is the column that we are calling up. So we are using this column to kind of filter it with only the petrol value. So that brings us to this plot. So we use now our newly filtered data set here as our data right here. And again, our x-axis and our y-axis, and then this just to show the color. So this shows the price mileage relation, but for only petrol cars. Kind of looks similar to this. but now this is just showing you the only petrol cars. And all this is consistent down, as you can see also for the diesel, showing a slight difference, but with the same coding that we've used here to just show the scatter plot, again, showing the relation that is a very negative relation. Our prices kind of go down as mileage increases. And this also you're going to see when we do our correlation plot later on. So again, same thing with the hybrid, just filtering out and trying to get a scatter plot of mileage price, but again, only for hybrid cars. Same kind of consistent kind of plotting again. So that's why you can see when you run it as a one, there's a lot of clogged up. Again, it's still clogged up, but now you've filtered them in terms of petrol, sorry, in terms of fuel type, and it gives you same plot, but now specifically for your fuel types. So next is a correlation. Again, correlation doesn't equal to causation. So you have to kind of dig deep, kind of understand your data set. Does it really make sense when it comes to the correlation heat map like this? So let's try and look at our data set and if we can tell a story from this plot or this heat map here. So year of manufacture and price. It's quite obvious because I know most of you guys or all of you guys have cars, and as much as a car model is new or has been released in the current year or is the latest model, the price will will always be up because of the new features upgraded. And you can see now here we have a high or a positive correlation as the price increase, as the year increases. You remember I told you we could have changed this to a date time or a time data type, sorry. But just for sake of data visualization, you can see here it makes sense. As our years continue going up, the price increases. So our price increases as our years goes on. So that this shows a high or a positive correlation. Let's look at the year of manufacture and mileage. From our obvious from our obvious reasoning, new cars have the lowest mileage. So that's why you can see this negative correlation here. It doesn't like give any story because it's quite obvious for this type of correlation. But as you can see, it shows you like here, for sure it's a negative correlation because the latest modules is equals to the current year or the latest year's release, which obvious have less mileage. So as you can see, the latest year is equals to the lowest mileage, showing a negative correlation. The year of manufacture and the engine size, there's a negative, but again, you can see this doesn't even make sense to have a correlation from this. So for this, we ignore. This here is just the same with this. So that's why you can see there's a positive correlation just because the same, given a one. So all this you just ignore because it's the same variable. Let's look at another correlation between uh, engine size here and price. From our scale here, you can see it's like a near or above average. So yes, the engine size has a slight positive correlation with the price. So yes, Nicholas, go ahead.
In terms of the correlation, would it be positive or negative? What information can I actually gather and how can I use it?
Sorry, say that again.
You mentioned positive and negative correlation. What I'm trying to get clarity on is how the information is valuable. How can it be used?
Oh yeah, so this this kind of plot is valuable when it comes to wanting to know if two variables affect each other. So if you're trying to give a story or to tell a story about a data set, and you're trying to see if kind of two variables, do they really affect each other? So if I increase this variable, does it affect uh, the other variable? So that's why we have this plot. So for example, when it comes to, just to give you an example, engine size and price here. So you can see there is a slight positive correlation. So it means that as we increase our engine size, then our prices go high. And this can happen to different variables. So this was just an example just to show you how two variables relate to each other, and does one increase affect the other? Does that answer your question?
Somewhat. But okay, let's say I don't have any prior knowledge when it comes to engine size. I don't know if a larger engine size
Mhm.
will increase the price, if a smaller engine size is going to increase. How how can I interpret that? Like, how would I know, okay, a positive engine size is going to cause an increase in price, just looking at the plot?
Yeah, so as you can see, just to tell you the relation, if you want to know is positive or negative, you'll always use this here. So a positive relation going is always higher, and then a negative correlation shows you a negative number of value. So just to answer you is that it depends with the data set, and it's just by seeing the plot. So when you look at the plot, after you plot them and you have this heat map or a correlation plot, you kind of now compare the two variables, and you can tell it by how they perform in this scale. You get it now?
Yeah, that's clear. Appreciate it.
You're welcome. So as you continue with the engine size, as I've explained with price, a slight positive correlation, comparing this with our scale right here, which 0.4 kind of falls slightly below 0.5 here. So it shows a slight positive correlation. So engine size and mileage again, this doesn't really make sense, and you cannot even tell a story between an engine size and a mileage. Then the same way a engine size and the year of manufacture, that you can see the negative, showing this actually no correlation between these two. So mileage and price, a negative correlation, just to show you from using our prior plot here, you can see this is a negative correlation or a negative relation between price and mileage. Why? Because as the price increases, the mileage decreases. So as the mileage increases, the price decreases. So you can see the higher the mileage, the lower the price. And this is evident when you come here, you can see our blue color mapping, which shows the negative correlation down here. It's a negative 0.63, so showing that this is a negative correlation. So as you increase in mileage, then you decrease in price. Same way right here, when you try to increase price, then it means that the mileage has to decrease. So as you, from just to connect it to a data set, cars which have low mileage are priced higher, and cars which have high mileage are priced lower, so have low prices. So that's why you can see the mileage and the price here. Again, mileage and the year of manufacture, you can remember as I explained you down here. And then last but not least, price, just showing what I have explained with the mileage, engine size, and year of manufacture. So this shows you the relation between our numeric variables, and you can tell if an increase of one of them, does it affect the other variable, which, the core variable here is price, because you're trying to do as much sales as possible. So again, if you want to have more cars being sold, you have to check on the correlation. So again, if you have mileage cars which have low mileage, then it shows that you're going to have more sales. Engine size, it just shows that the price goes up, but it doesn't show that we sell more, but it shows that it affects the price of a car. So our next here is a line plot, just a simple plot to show the average car prices by year of manufacture. So you can see we've grouped it. You can remember that this is what we did in some of prior classes where we're trying to group, trying to aggregate or to filter, as you've seen in this class also. So here we are grouping the year of manufacture with the mean or average price, as you can see here, and then we plot it. So it just shows you what we've been talking about, that the average price increases as the years goes by, and this is obvious, and it's more cars as more cars continue being released, they come with different features. They are kind of more modified, so it shows that the price continues to go high. So this is just a line plot showing the average price against the year of manufacture. Then the next one here, just to wind up on our data visualization, it just shows again how to filter. You filter the fuel count in terms of how the fuel types are, or the value counts of the fuel type column appear. And you can see that from our data set, all cars that have a fuel type of petrol, we have a higher number of those cars compared to diesel and hybrid. So this is good when it comes to statistical summary and just trying to help people understand your data set. Again, same plot, but using Seaborn. And as you can see from here, there's just something slight difference between Matplot and Seaborn. Here, Matplot, you have to count it for yourself. As you can see here, we counted it. But when you come to Seaborn, you just call the count plot, and then you just tell it where do you want it to like count, what type of values, which column do you want it to count, which is a fuel type column. And then it just counts it without you having to write the code or without you filtering it yourself. So Seaborn, as I said, is simpler to use, and it's built on Matplot. So you can see same plot, but with more feature and easier code. And that's it for our class today. Any questions? I would recommend you guys to download as much as more datasets from Google and try to practice this. You're not going to use the same plots in different datasets, but it's just good for you to practice, and then slowly but slowly you're going to understand how to play along with these features and with these added features, and how to kind of modify your plots. Any questions? And just to remind you is that these plots should be answering questions that you have, or the questions that you're trying to answer depending on your data set. So might it be questions like do new cars always cost more? This type of questions. So you have to have like a question that you're trying to answer with your plot, not just plotting for the sake of, but you're trying to answer questions because, again, as a data analyst, you're trying to give valuable insights about the data set that you have. So all these plots are for giving insights in sync with your questions that you're trying to answer. So any questions? Well, if you don't have any questions, you can feel free to drop, but I'll be just here if you want me to go through anything or explain anything more deeper. Thank you.
Have a good night.
Thank you, you too.
All right.
Thank you.
Thank you. Thank you.
You're welcome.
Hello?
Yes, I can hear you, Nicholas.
Yes, I don't know what you have planned for the class, but so far I understand everything that you're doing in terms of the practical aspect, but in terms
Mhm,
of me developing hands-on skills, I don't know if that's
mhm.
supposed to be part of the plan regarding this course.
So, in terms of your hands-on, are you thinking of a class where we just do hands-on, or because again, I'll just give you the important codes and the important things that you have to do when it comes to data analysis. Then you can always practice this by your own. Or what are you thinking of when it comes to hands-on?
So you think it would be better if I just like practice on my own and come to you in terms of if I have any questions or so on?
Yeah, I think that's the best thing because again, if you
Mm-hmm.
practice with me, you're not going to grasp anything because it's like you're just kind of copy pasting. But if you try
Correct.
it by yourself, you kind of run into errors and try to kind of correct them. And if you can't, again, if you do
Mm-hmm.
research and you can like solve the error, then you can get back to me. Or if you want me to expound maybe uh, a concept when it comes to the hands-on, then I'll be happy to do it. But it's always good for you to kind of do it on your own. Just
Mm-hmm.
try and run these codes, try and play with them, and then if you have a question, don't hesitate to ask. I think that's the best way. Practice, then you ask questions whenever possible.
Okay, I just wanted to have that clarity because I don't know if you were planning on probably giving homework, like when you finish giving us the theory, then to know what we grasp and what we don't understand, so you know exactly which area to target.
Oh, okay, I get you. You're thinking of like a exercise kind of approach, right? Where it's like I'm
Yeah.
giving you a data set, then I tell you guys to uh go and try and get these answers. Is that what you're thinking of? I can do that for you if you feel that's the best way you can understand and grasp this concept. I can be able to write questions where I'm asking you,
Mm-hmm.
try to, for example, in this data set, I can tell you, can you try and retrieve the last 10 rows? 10 rows in this data set, then you can go and do a research on your own. And if you don't get answers, then you can come back to me. I think that's the way that you want us to approach when it comes to hands-on, right?
I think that's kind of the way that I'm accustomed learning, but I don't know if you guys had anything planned, and I don't know if you noticed from the class. Everybody would just be, I don't know, well, I don't know what level they're at because every node there's not much participation, so I don't know if is it that a case where I'm way behind and they're advanced, so this is probably like revision for them. I don't know.
Yeah, this class is more of a basic class, but I
Okay.
understand your concern. Yeah,
Mm-hmm.
and it's a good concern because as we talked to you, you told me that you want to continue like improving in data analysis. So for you, you're trying to continue like you've already interacted with data analytics. It's not like yes, you're new to it, but you've continued interacting with it, doing your own courses. So I get what you're saying when it comes to the exercise approach and practice
Mm-hmm.
approach, but most of the guys, I believe this is the first time they're seeing this. So it was more of a intro, but again,
Okay.
I'll think about it and I can be able to prepare like a notebook like this, but with just questions, and then you can try on your own. Then we can go through it in the next class. You think that's the best thing? I think that's the best approach from your concerns, right?
That sounds good as well. Also, being
Mhm.
able to do what you are doing, because I don't know if I'm able to do all the programming to even reach to the point where I'm able to visualize the data and actually explain it to, let's say, a stakeholder or someone else using
Mhm.
this system. Uh-huh.
Do you think if I sent you like more resources where they have these codes or they have the documentation of this of maybe Matplot, Pandas, NumPy, and Seaborn, do you think that's going to help you to start practicing? Because they always have these documentations where they are going through codes and you can be able they
Mm-hmm.
explain how to use them like from a beginner level as they continue upgrading. Do you think that's the best way? I can send you the resources which you can be able to practice on your own. Then, as you said, you can always come back to ask me questions in case you have any.
I'll appreciate any approach. I mean, at this point, it's trial and error since I'm somewhat new. So it will be a trial and error. But I just don't want to just come to class and just listen.
Or
I
just
want to
watch,
have
yeah.
yes, I want to have a clear understanding. So, like,
Mhm.
let's say at the end of this, I don't, how long is this course supposed to be?
So this class was the last one when it comes to the intro, as we were
Mm-hmm.
talking. This was the last class in data visualization, but we are it's like we are gonna run it back just to grasp and try to explain more when it comes to the concept. As you said, yes,
Mm-hmm.
you've understood the basics, but again, for the sake of grasping every concept, we might kind of run it back again.
Okay.
Yeah. So just to ask
Mm-hmm.
you, in terms of this class, have
Mm-hmm.
you like tried this like just to inspect and understand your data set? Have you tried these codes?
No, apart from I think there's only one exercise where I actually try anything on my own. I think you sort of give us like a homework.
Mm-hmm.
Yeah, so that's the only time that I've actually been hands-on. Apart from that, I've just been trying to review and try to get across of what's going on. But I wasn't clear in terms of what's the plans for the class.
Oh, okay, okay, okay. I understand it because again, you might grasp the concept, but if you can do it on your own, then it doesn't
Yes.
make sense. Yeah.
Mm-hmm.
So I think I'll share this with you guys just for the sake of practicing. Then again, I'll get back to you in the story about exercise approach and give you a new like an assignment just to gauge what you if you've understood it. Then if you have questions, we can discuss them in the next class. I've noted that.
Appreciate it.
So yeah, I
Mm-hmm.
got you. Yeah. All right. Any
All
more
right, thanks,
questions?
Atman. No, that's all for now. Oh, I think I've noticed one thing.
Mm.
When you were, yes, like right there, I realized that for the rows they start from zero, but for the columns they start from one. Is there a reason for that?
Oh yeah. Oh, right here.
Yeah, you realize for the row they start from zero, but for the columns they start from one, counting from number one.
Yeah. Have you like interacted with coding in any programming when it comes to indexing? Have you tried to?
No, none whatsoever. First time.
Okay. Yeah. So in terms of indexing, it starts with zero. I this is more of I haven't touched it when it comes to the pandas and NumPy,
Mm-hmm.
especially pandas, I think, where there's other methods where you try to do your data analysis in terms of let me think, because this was just a kind of introductory course, but there's deeper codes when it comes to or methods when it comes to pandas. Let's say you want to filter a certain value here by calling the number of the row.
Mm-hmm.
So with that, you could have understood about indexing where it starts from zero and not one.
Okay.
So
Okay.
if you haven't done any programming, but I hope that this class is going to move to the maybe intermediate one, and you can be
Mm-hmm.
able to to kind of interact with this when you're trying to filter values from your data set. Because
Well,
because you
mm-hmm.
can always call by referencing these numbers here, which are indexing, and then they can return it. That's what you can see here. And again, if you try to run, to, I hope it's going to work here. You can see
Yes.
now there's here, you can see. So it's more of indexing, and it's a simple concept where when it comes to indexing, and this here is just it starts from 0 and not 1.
Okay. Okay.
Yeah.
Just an observation. So I think I got some clarity now. The other thing is in terms of the coding,
Mhm.
give us a cheat sheet. Would you
Yeah.
recommend memorizing it, or is something you guys get used to over time?
You just guess, you get used to it over time because you realize that there are some of the codes are kind of consistent in every data set. Because,
Okay.
for example, if you're trying to understand your data set, you see some of these methods like shape, tail,
Mm-hmm.
describe, columns, you're going to use it over and over. Data
Okay.
types, you're going to use it over and over. Then you'll just grasp it, and it'll be like easier for you to use. So some of the codes or the
Mm-hmm.
method that I gave you on the cheat sheet, you're
Mm-hmm.
going to use it like numerous time. You're going to grasp it. It's gonna be like a just some like an habit or a normal thing for you. As you
Okay.
continue practicing, that is, yeah.
Okay. Well,
Y-
more reason for us to have some more practice. Okay, I appreciate it, man. Thanks.
Yeah, you're welcome. So for just before you go, you can see
Mm-hmm.
when it comes to this plotting of data visualization, this is just practicing. And once you grasp this, which is kind of easier, you can always modify it as much as you want. So once
Mm-hmm.
you start interacting with it, then you'll see how it kind of makes sense to you. Right now, because it's a new concept, you feel overwhelmed, but when you go and try it on your own, you're going to
Mm-hmm.
see how it's easy like to grasp all this.
Okay.
All right, Nicholas.
Good, good. Okay, thanks, bro.
Okay, you're welcome. Have a
Yeah, have a
good
good
one.
night. You too.
You too,
Bye.
bro. Bye.